Hello everyone, welcome to SMT Call. Today we are going to solve the day 21 of September LeetCode challenge. Today's problem name is carpooling. So let's try to understand the problem statement first, what we need to solve today. So here we can see that we will be given two inputs. One will be the trips, another one will be the capacity, and in each trip array there should be three fields or three value. The first value means the number of people, second value is the starting point, and third value is the destination point. Okay, so basically these all are one trip information related to one trip, means how many number of people will onboard in our car, that when they will onboard and when they will reach their destination, right? So and we need to check, we need to iterate through the all trips array, and we need to say that we need to return either true or false. So if I found that if I can accommodate all the people whichever in the trips array, then we can return true. Else if we are not able to accommodate all the people in our car in this journey, then we need to return false. Okay, so this is the problem statement. So you can see this. So our capacity will be initially given, right? So if you check the first example, right, here our capacity is 4. That means at max we can take 4 people. Okay, so now my car will be start from here probably. So this is probably think about the second kilometer or second destination. So here I will come, my car will come, and I will pick. I can see that there are two peoples right here, and the starting point is 1. Okay, so I will pick 1. I will pick 2 people. So my capacity will become now 2 because my total capacity was 4. Now I know that these 2 people will reach at your destination at 5 kilometers or something like that. Okay, so now again we will move forward. I will check the other trips in our array, right, input array. Here I can see that here we have 3 more peoples, but still my capacity is 2, right, because those 2 peoples are still in our car, right? So in that case, in any scenario, we are not able to accommodate all the peoples in the trips array, right? So we can return false. But if you check the second example, here our capacity is 5. So for the first trip I can pick 2 people. In the second trip I can pick 3 more people. So it's not exceeding our capacity. So in this case we can return true. But for the first case we can see that it's not possible. So we are returning false there. Okay. So how we can? So we are going to see a couple of approach today. So at first let's see that we can use priority queue, and using priority queue we can solve it. So how we can solve it? So probably if you check the test cases properly or given example properly, it's not guaranteed that our trips array will be sorted according to the start time, right? It can be jumbled up in some scenario, right? Okay, so probably we need to sort that array first. Okay, so we are going to sort our array according to the start time, and then probably I can use one priority queue, and in the priority queue I will my priority criteria will be whichever trip has earlier destination time, that will be in the top, right? So whenever I will poll my priority queue, it will always pick the trip which has earlier destination time. Okay, or destination point you can say. So after that we can so after onboarding or after picking new trip, we can keep checking the capacity, right? If I see that at any point of time I am exceeding our capacity, then we can return false, or at the end we can return true. So let's quickly see so you can see the code here, right? So here we are sorting the array according to the starting point. Then we are taking one index probably, and for keep tracking the index means which trip I need to pick one by one. So I am taking another priority queue also. In this priority queue we are maintaining the trip according to the earlier destination point. Okay, so whichever trip we will have earlier destination point, that will be in the top. Okay, so now we are checking that. So suppose I want to pick, I am here, right? I already have one. I already picked up one trip. So I will check that so whenever I pick the next one, I need to check can I poll or can I remove this trip, because if I see that its destination is reached, then I can remove this person, right? So that I can reduce or I can increase my capacity, right? So we are checking that here, right? So if I am checking that can I drop some trip here or not? Then I am going to drop that and I am going to recalculate my capacity, right? Or else if I am saying that I will not be able to drop anyone, then I am going to check that if I pick this second trip, will that exceed my capacity? If yes, then we are going to return false. Or if I see back like in the second example, right, if it is not, it will not exceed because our capacity is 5, then we will go ahead and we will onboard those second trip also, right, or we will start the second trip. After that, we will keep checking for all the values. So whenever I will see that my capacity exceeding, we are going to return false, or else at the end we can return true, right? So this is one approach, okay. But what will be the time complexity here and space complexity? Since we are doing the sorting, right, it will at least take order of n log n time. Also, we are taking priority queue and we are iterating through the whole array, whole trip array, right? So that will be also order of n. So total time complexity will be for this approach will be n log n, okay, and time space will be also order of n since we are using priority queue, okay, in worst case scenario. So so this is one solution. This solution should be accepted, but we will try to optimize this solution also, right? So how we can optimize it? So here we can see that we are doing sort and all, right. So that basically that the sorting thing is increasing our time complexity. So probably we can use bucket sort kind of thing here, right? So if I use bucket sort, then we can solve it in linear time. Linear time means order of n. But how we can know the bucket? We can use the bucket sort. If you read the problem statement, they are saying that our trips value is the boundary value of the trips is up to 1000. That means I know that at max we can have 1000 destination point, separate destination point. So what we can do? So probably we can take one array that will serve as bucket, right? So whenever I will, so suppose I am here, right? So I will pick this trip array and I will pick the starting point, right? That means I know this is my starting point and I am going to update the total number of here, right? So it should be 2, and I also check the destination, right? I will see. So suppose what I will do, I will pick one array at a time and I will check that for that particular start time what will be my capacity, and for that particular destination time what will be my capacity, right? We will check that. So initially I can see for time 1 I know that initially it will be 0, but for starting time 1, sorry, my capacity will be 2 since it had 2 capacity, okay. And in the similar time I will also check. So 1 2 3 4 5, so here, right, I will check here, this is 5, right. I will know that it will be -2 because I am going to onboard 2 people from here, right. Now I will move further, I will check this one. So here again I will see my starting time is 3, right. So it will come here 3, again it will be initially 0. I am going to add 3 more people. In this case, in 7 those people will be onboarded, right. So in that case, or reach their destination. So in case of 7 it will be -3. So now I can easily create separate bucket according to the timestamp, right. So timestamp or starting or destination point you can say. Then we can iterate through this bucket, right, and we can see that in any point of time we are exceeding the capacity or not, right. If we are exceeding capacity, then we can return false, right. So let's try to write the code for this second approach, right, because we already wrote the code for first. Now let's try to see the second approach also. So for this approach we are going to use bucket sort. So I am going to declare one bucket array here, so let us name it as bucket only, and we know that its size cannot be more than 1000, right. So it's a fixed size, right. So it should be 1001 since index start from 0, okay. Now what else I need? Do I need any other extra variable right now? I think we don't need any extra variable right now. We are going to run one for loop and we are going to pick one trip at a time, okay. So let's do that. So it should be int, let us name it as trip, and we are picking one trip at a time from the trips array, right. Now what I need to check here, I need to insert in the bucket, right. So at first I will insert the capacity for the start time, then I will insert the capacity for the as per the end time or destination timestamp, okay. So I will do that. So I will update my bucket, and initially we are going to consider the start time. So that means start time is stored in the first position of the array, right. So it should be bucket trip +1, and we are going to update it according to the capacity, right. So capacity is stored in the 0 location, so it should be trip 0, okay. Now what else? Now I need to update. We need to update the capacity for the destination time also, right. So let's do that. So it should be bucket, and in this case destination time will be stored in the second position, right. So it should be trip 2, and in this case we are going to decrease since people are reaching their destination, right. So it will be the negative value. We are going to decrease the value, right? Actually, so it should be again trip 0, but it will be negative value, right, or decreasing value. Okay. So now using this for loop, we can prepare this whole bucket, right? That means I know for a particular timestamp, my capacity at that point, my capacity will be what? Okay. Now again I can run one for loop. So again I can start from int I equals to 0, and I should be less than obviously the num bucket dot size bucket dot length, and we can increment I one by one, right? So it should be I plus plus. Now what I need to check here, I need to keep adding the capacity. So let's take another variable, but it should be outside the for loop, right? Sorry for that. It should be outside the for loop, and we are going to take another variable named capacity, or let us name it as temp capacity. Okay, and initially it will be 0. So I will run through my bucket and I am going to update my temp capacity, right? So it should be temp capacity plus the current bucket value, right? That is the current capacity for that particular timestamp. Okay. Now I will keep check that if my temp capacity at some point of time is greater than the input capacity, then we can return false, right? So we will return false. That means it's not possible to accommodate all the peoples. Okay. Else we can return outside the for loop, we can return true, right? So let's do that. And now let's quickly submit our answer and check whether it's accepted or not. Okay, I think our solution is accepted. Let's try to see the running time. Okay, so you can see it's beating the 99.28% of Java submission. And if you check the time and space complexity for this, you can see that we are running 2 for loop, but those for loop are not nested, right? And we are not doing any kind of sorting also, right? So in this case, we can solve it using order of n time, right? Since we are running only for loop till our size. So it will not be order of n actually, it will be order of max of n or 1001, right? Because we are running this up to 1001, right? And again for space complexity, it will be constant. So it's not dependent upon my input length, right? Because we are in each and every scenario, we are going to use the fixed bucket of size 1001. So in this case, our space complexity will be order of 1. Okay. So now let's try to see, can we optimize it much better way? Because suppose it's not like that every time we will have input till 1001, right? So in most of the test cases, we will have smaller number of inputs, right? So I think we can optimize this for loop, right? So how we can do this? So let's do 2 more variable, probably int max, and another one will be int min. So what I will do here, so whenever I am creating my bucket, I am going to keep tracking my starting index, minimum starting index, and the maximum starting index, so that we don't need to run the for loop from 0 to length. Okay. So let's do that. So what we can do, so I will keep updating my max value, right? So let's do that. Let's do one thing. Let's initialize that integer dot mean value, right? Mean value. So initially we are going to assign one minimum value, and for max we are going to assign one maximum value, right? Dot max value, and we are going to keep updating this max for each and every tip, right? Max and min both. So for max we are going to use math.max function, and we are going to update. We are going to take the maximum value between the current max or the. So in the max we are storing the destination, right? So it should be always trip 2, right? Whatever the trip 2 value or the earlier max value, I am going to keep updating our max like this. And similarly, we are going to update our mean. So for mean, we are going to take the starting point value, right? Not the destination point value. So it should be mean, and again it should be the starting point timestamp. So it should be trip of 1. Okay. So now I know that for that particular test cases, where should I start and where should I end, right? Because in this case we are iterating blindly, right, from 0 to n. But that is not required for all the cases, right? Test cases. So it will improve time complexity up to some extent, right? So it should be less than equals to max. Okay. So now let's quickly submit it and check. Okay, you can see it's accepted. So now let's try to see you can see that this time it's beating the 100% of Java submission, right? So we are saving some spaces by using this max and min. Okay. But again, the space complexity will remain same here because it's constant. It's not dependent on the input size. I think that's pretty much for this video. If you like this video, please subscribe to our channel. Thanks for watching. Bye bye.